want to welcome you. I'm Ginny Peterson, and I've done introductions before and looked out at the faces I'm looking at right now, and I want to thank you so much for coming back to the Tony Woyak History Festivals and supporting these programs. It's always a little, there's excitement in the air when we get ready to present. We want to make sure everything's good and everybody can see and everybody's comfortable, everybody can hear. The WHA, the Washburn Heritage Association, got a grant this year from the Washburn Community Education Fund, and that along with some of our own funds, and we did buy some new sound equipment. And right, okay, I get it. And also, we're working with our visuals too to get that right. And this is a different space, so this tonight is kind of a dry run. But let us know, what works, and also let us know what doesn't work, because we'll try to make it better every time. So welcome again. I'm looking at my notes here. Welcome back to the Tony Woyak Winter History Festival, presented by two local organizations. It's not just the Washburn Heritage Association, but we team up with the Washburn Area Museum, or they used to call themselves the History Society. So a little name change, same organization, and so the two of us often do kind of parallel things, but this is the one thing that things that we do as a team, and have since the 13 years ago when we started. So thank you. Tonight, as we begin our 13th season, we want to thank you for being here, and we're very honored to be able to share the stories of Washburn with you, and appreciate your continued interest and enthusiasm for them. We also thank the Harbor Table for hosting us once again. They've done a nice job of helping us set up this back room, and we're going to see how that goes. And we have someone else to thank tonight. We were a little nervous about getting all this equipment and not knowing quite how to use it to its best. And so we hired someone locally, and that is James Staff. There he is. He's hiding. I got it written down. I thought I could remember it. Shaftstall. And he's a local guy. He sings with the Schwammergan Choir sometimes. He's a singer, and he's a musician, and he's opening a business sort of kitty corner from the post office. And he's going to do a number of different things, but among them, rent musical instruments to high school kids and kids, essentially. And so it's nice to have that new business in town, and it's exciting that he's offered to help us. He's going to be shepherding us through the winter season. And so how are we doing so far? All right, good. Thanks you to James. Thank you again to Andrew Grimm, who is our teacher at the school and is our video recorder, so that all these Tony Woyak programs can be found on our website, downloaded free. You can watch them whenever you want to, going back not quite 13 years, but a long time, and we've been able to preserve that. Well, we hope you'll be able to enjoy tonight's program. And our speaker is not Raylan Pearson, as was advertised in our brochures. Raylan couldn't be here herself, so she's passed this job on to her son, Taylor. He was all set to go yesterday, and then something happened. He's not feeling so well this morning, so the job got passed along again. So it's a lucky thing this is a family operation, because tonight Cole Pearson is here, and he was very humble about saying, he's going to put it together, but yeah, that's right. Thank you for that support. I was going to ask you to give him a warm welcome, and knowing that he works in a foundry where they melt iron with heat from big furnaces, he might want his definition of warm might be different than ours. So let's try one more time and give him a really warm welcome. Cole Pearson.
Can everyone hear okay back there?
Yes.
Okay. Yeah, I got a text from my brother this morning saying, I'm not feeling too good, so I'm not going to be into work. And I'm like, okay, that's no big deal. You know, that happens often enough. And then he's like, oh, you're going to have to do the presentation. And I'm going, oh, that changed what I'm doing today. So here I am presenting this. Luckily I know a decent amount about the Foundry, given I've worked there for a while. But I am presenting a PowerPoint that mostly someone else put together. So you might have to bear with me a little bit on it, and I apologize, I do have to kind of hang here because I have a lot of notes. Hopefully you guys can see. I'll try to move around a little bit. So yeah, as mentioned, Raylan had a schedule conflict. Taylor, I don't know if he's really sick. He might have just said. But here I am. We want to start off by giving a general understanding of what it is that a foundry does. That way, before we get into a little bit of the details of history, everyone kind of has a concept of what the industry is. So basically, Foundry is a factory that produces metal castings. Metals are cast into shapes by melting them into a liquid, pouring the metal into a mold, and removing the mold material after the metal has solidified. This is most common metal processing, and the most common castings produced worldwide would be iron and aluminum. There's also brass and gold and bronze and all of that. But generally speaking, for majority of casting use in the global economy, it's going to be aluminum and iron. So what is a casting? The making of an object by pouring molten metal or other material into a mold. Our molds are made from sand. Our sand is black after we use our additives to it. Essentially, we take a pattern that has an impression that will make a void within the sand mold, and we pour molten iron into that, it solidifies and it shakes out. There will be a short video here in a little bit that you'll kind of get the concept of it. The process of casting dates all the way back to 4000 BC. So it's a very long driven, process. Very long time. It's also very critical to basically almost every aspect of what it is that we know our day to be on a day-to-day basis globally. We're foundries dating back from 4000 BC essentially are the original recyclers. We take scrap material, a product that's been discarded, we'll receive the scrap material, blend it into a recipe, melt it down, and produce another usable part. Oh, skipping up here. I should have hit the button a couple of times. You guys would have seen that. Why is a foundry important? Do I use castings? Essentially, if you drove a car, rode in a car, walked down here, rode a bike, to get down to this facility, you used a casting. It's generally known that more often than not, within 10 to 15 feet of where you are right now, there's a casting around somewhere. So it's used in every aspect of our life. So it's very, very important for the way the world is today. Hopefully I'll get the gist of this slide before the end of it. Okay, so here comes a video of the general process in our facility. Getting back to giving all you guys a better understanding of what it is that we do, and then we'll get into the history of it. I might pause it a few times to elaborate a little bit. So this is going to be a video of us making the pan. So if you guys can see that video, we're mulling and mixing sand here, and you can see there's going to be a little. Let's see if I can pause that right there. There's a little dribble of white sand. So that's silica sand that we bring in from Badger Mining. Every batch of sand, this black sand down in here, if you can see it, I know it's kind of dark, we reuse. So not only are we recycling waste metal, we're also reusing our sand. But because of the thermal shock that the sand gets from pouring molten iron onto it, we have to add about 0.6 to 0.8% new sand per batch. And a batch of sand is 2,500 pounds. This is a muller in our facility that's mulling the sand, getting it ready for production. It does quite a few tests before we even get it to the molding machines, before we even use it. Here's the sand controls here. So the sand control system, I skipped it there. Sand control system will check compactability, moisture content, shear strength, temperature of the sand. If it doesn't meet our set criteria, our automation sand control system will kick that load of sand out and it won't even make it to the molding machine. This picture here that I paused here is a automatic sand molding machine. This bottom half is called the cope, or the drag, and the upper half here, which is in the flask, is called the cope. There's always going to be two sides to a sand mold, and there's a pattern. It's hard to see, but there is a pattern in here that creates the cavity of the casting that we're producing. We'll let it go through here for a little bit. So the mold is now done and completed. Right there is actually the pattern, because that mold was closing over. That mold will be kicked out onto a handling line where we will then put molten iron into it. Here's a relapse of how that machine makes a mold. It's dropping sand in there, it's doing a vibrate and a compression, drops down, the cope was made up in here, drag is being dropped, and the pattern will get retracted into the machine. And you can kind of see that's our little griddle top there on the bottom. Molds come on out on a handling line where they will get staged onto our pouring deck. This video is a little long here, I would say. So all this is automated right now. This video, I believe, is from probably 2014. Judging by that molding machine that's there, we've upgraded that one since this video. So here is our electric furnaces. So we use a lot of electricity in our facility. These are medium frequency furnaces. These hold 3,300 pounds of iron in them per batch, and we bring the base iron up to 2,750 to 2,800 degrees. So what we're dealing with is hot stuff. Hot stuff. And feel free, if anyone has any questions at that particular moment, just raise your hand. I'll see if I can answer it. If not, no big deal.
So does it get molten?
What's that?
What temperature does it get molten at?
Iron gets molten at right around 2,300 degrees. Okay. We have to bring it higher than that, A, so we can have time to handle it, but B, also we add a lot of carbon and alloys, copper, silicon, and carbon needs a long time to get into solution to make the specific iron we're making. And it's a good question. I'll touch base on that. We don't just make iron. I mean, yes, it's iron, but within that realm, there's multiple classifications of iron. There's gray iron, and then there's ductile iron. Within ductile iron, there's many different classifications of iron, and based on that, we are changing the recipe of our base iron on that particular charge. So it's very dynamic, and it's a lot like being a chemist. There's a lot of additives that have to go into it. Temperature plays a role, the carbon, the alloys, the silicon, the manganese. We even put rare earths like moly in there. It's a lot different than the aluminum industry. Aluminum industry buys ingots, and they basically heat them up and they pour them. So that's a much simpler foundry to operate. In the iron industry, it's a totally different game. Basically, we're chemists. Go ahead.
Is the electric heating, is it resistance heating, induction heating, or?
Induction, yep, so it's a medium frequency induction furnace. Yep, so there's copper coils in there that has water running through them to keep the coils together. And there's also power running through those as well. And it will actually focus the magnetic energy field into the pot, churning and creating the material to move around and heat up. Yeah, it is magic. I know what we have, but yeah. I work on the furnaces, but yeah. So you see this one's pretty much up to temp. They're pouring it right now, so they're lifting up our furnace and they're gonna pour it into what we call a teapot ladle. And a teapot ladle is how we transfer our iron from our furnace deck throughout our facility into different pouring locations. 600-pound ladle. He's adding some inoculant and carbon. That'll go on an iron buggy here, and that's fully automated as well. The furnace operator will pick and choose which molding machine gets it, and it'll automatically stop in there.
Is that an insulating blanket on top?
Yes, yep. Keeps the iron as warm as possible, and also kind of protects the iron pour as he's pouring it. You'll see that up here where they transfer it up. So he's taking the lid off here, and he's taking a coagulant which collects all the impurities on top of the iron. It's called slagging it off, and he'll remove it with angle iron before we want to pour. If we pour any molds with that in there, you're going to have a lot of porosity and voids in the casting that will make it an unusable part. Go ahead.
What's the sound like?
The sound?
I mean, there's no sound of it. When you're there, what do you hear?
You would hear lots of things. Buzzers, when that iron buggy runs around, it's very loud. It has like a beacon on there so people are aware that it's coming. Here, when he's slagging off, you would hear a lot of crackling with coagulant that's clumping all the slag and impurities together. A lot of hydraulic motors and pumps going. And then up by our shakeout, you would hear a lot of tumbling of castings. So in some areas it can be very loud. Most areas it's not terribly loud, but it's I would say a typical industrial manufacturing facility. Go ahead, Bob.
How warm is it for that guy standing there?
It's decently warm. That's part of why we have that Cerawol that we put on there, that white Cerawol on top. You can see he took the temperature of this ladle and it's 2,672 degrees. Our teapot ladles also have like a shell in there that helps keep the temperature in so it doesn't cool off too quick and also protect the iron pores. It is a little bit hot, but the guys kind of get used to it, and in the summertime we hand out a lot of liquids and cycle people through there.
Can he see the slag on there?
Yeah,
He's got
you can see it with your naked eye. Yep. If you don't use that slag away or that coagulant to get it clumped together, as soon as you take that lid off, you would see some impurities floating on top. The coagulant just kind of clumps it together, so it's easy to scoop it out.
What is the stuff on top of these things? What is it?
It's like impurities from the remelt material. It could be some sand left over in a gating system. Also, we bring in a lot of scrap material. So it could be rust, could be other, dirt from how that scrap was stored or whatever. Any kind of impurities, essentially. And then here is, after they take the temperature, here they are pouring out of the ladle into the mold. So we always pour from the top. We go through a gating system. This is going to fill the cavity that is made in that mold from the pattern, the shape of the pattern. It's going to solidify over time, and then that mold will get kicked out, and you'll have a casting here. You'll see it come out here off the mold handling line. Everything's fully automated besides the pouring at this point. So there's a little griddle that we have coming down our shaker conveyor system, and this is going to go into our shakeout system where we will separate and reclaim all of our sand for future processing or future use. It's going into a drum there. It's called a ditty, and it's a rotary drum that tumbles, screens out the sand before it goes back into our. You can kind of see it there. Castings tumbled. In this slide or on this presentation ahead of us here, that we've done a lot of internal upgrades. So knocking off the gating. So we have a. I don't know if you can see it. It's not as blurry on my screen. Here's the down sprue. This is how we poured. So right here is a pouring dish. We poured from that ladle into the top of the mold, goes down a down sprue, goes down to a runner here into 2 contacts. Contacts is what is the cavity from the gating system to the part. It's how we get iron to the cavity within the mold.
And then it fills the actual cavity up from the bottom up.
Yeah, yep. With gravity, it's gonna go flow through, drop down, come up. You have venting and stuff too. Go ahead.
Could you repeat the question, because we can't hear it back here?
Good call. I will try and do that. She wants me to repeat the question. I don't know if I can remember all of them yet. From this point on, I will try and repeat the question. So now they're being handled, and they will go into, they're organized, because we do make a wide variety of castings on any given day. They'll go through a tumble blast system here, where the sand gets blasted off and the castings will get cleaned prior to finishing. It's a steel shot blast, tumble blast. I believe it's about an 8-minute cycle, and it can blast around 2,000 pounds at a time. This area is kind of loud. So you can see the castings are nice and shiny. They'll reverse the apron here, and those will get dumped out onto a hopper, and then we'll go to its next stage.
Do they ever break in there?
Sometimes. You kind of have to, he asked if the castings would ever break in there. We do have a different blast in-house too for more fragile castings. And we try to kind of blend maybe 1 or 2 different jobs, take a ductile small part potentially and mix it in with a bigger, heavier thing or a more fragile thing, so it creates more of a, like a, a cushion, so to speak, for the castings tumbling. So this is a top view of one of our finishers. So he's grabbing the castings, grinding them on a snagging wheel, prepping them to be shipped out to the customer, which I believe these were made for one of the homecomings in what date would that be? 2015, I think. Go ahead.
What are the casts? That looks like a skillet to me. What
It is. Yep, that's a little skillet that we have that we make in-house. We made it for a homecoming, and I believe it was 2015.
And so do you typically make always the same product or all sorts of different orders?
All sorts of different things, yep. And you'll see that in a couple slides here. We make, I believe we're at about 2,700 different patterns. So that's 2,700 different parts. A lot of that is agricultural stuff. So the big John Deere, Caterpillars, there's mining. We do sprinkler components. We do heavy truck. So it's the McNeely's cement trucks, fire trucks. Really, we'll do most of anything that fits our facility with the exception of automotive. We're not large enough to handle the volumes that the auto industry demands. I think we're getting to the end here, and then we'll get into the history stuff. I think that's why you guys are all here, right? Some close-up of some hand finishing of the skillets. I guess that's it. All right, it's over, guys. Good night. Okay. There is, I'm sure a lot of you guys know him. he was pretty active in the community. That's Otto Rusch. So he's the founder of the Iron Works as we know it right now. I don't want to just jump too far ahead because there's a lot of, oh, this thing's automatically going now. I gotta learn how to use this remote. You guys got pretty techy here. So Otto came up, well, here, I'm gonna go with this first. I don't wanna jump ahead. Again, remember, I'm presenting a presentation that was mostly done by someone else. We call it the two-story building, okay? That is right here. And I think most of you guys know it because it has that mural on the front and around the corner. It's a very old brownstone building. We call it two-story because it's 2 stories. It's basically our sand mauling operation currently. The 2-story brownstone building was built about 1900 and was once a W.H. Lemke dry goods store. That's what we were able to dig up. In 1940, George Malinowski started Washburn Foundry with the purchase of the brownstone building. The same year the primary gray building was built, right here. We put together this 3-dimensional kind of expansion map as we go along in this history. Indicate, let's see here, brownstone building year, primary gray building was built the same year he bought it. We don't indicate whether George bought the gray building or if it's built by him. 1969, George Malinowski built the building south of the brownstone building. That'd be this one here. And 1940 building, which was this one. The other buildings on there, I know it's just 3-dimensional. We don't have the dates on there, which would be this one and that one. So that's basically how it was when George took it over. Let's see if I can get this to work. Voila. So that's how the foundry was before Otto came in the picture. So Otto Rusch, which is my grandfather, came up to Washburn in 1975. He purchased the facility in February 1976. See here. When he purchased it, it was basically non-operational. There was only one light, the floor was dirt, and the furnaces were froze up. And what that means is they basically had a molten bath in the furnace that was there and they walked away from it, so it solidified in there. So it's not good for an induction furnace. So it was in rough shape. A little bit, I'm going to touch a little bit backstory on the history of Otto. He's basically been, as far as I know, a lifelong foundryman. He originally started working in a foundry called Washburn Iron Works down in Brillion, Wisconsin. I couldn't tell you exactly how many years he spent there, but
1948 to 1955.
There we go. There's one of his sons right there. 48 to 55. Thanks, Randy. And then from that point on, he branched off Brillion and started a foundry called Wapaka. So him and 3 of his buddies started Wapaka Foundry. Currently, Wapaka Foundry is the largest foundry in the world. So he had a lot to do with the foundry industry. If you leave this small community of Washburn and you go talk to other foundrymen throughout the Midwest and you bring up Otto Rusch, they pretty much all know. So he worked in the Wapaka Foundry for how many years, Randy?
19
years, okay? Taylor didn't have this in the slides, so. And then he decided to come up, and as it was getting bigger and bigger and bigger.
That's because he had 3 sons and none of us had a job.
So he had to get out of there and get some work for you guys, I guess.
That's right.
All right.
Get us out of trouble.
Yeah. So he came up in '75, bought the the building February 1976 from George Malinowski, I believe. Gotta keep on using this thing. Here's a couple news articles. They're probably really hard to see because they're newspapers from a long time ago. So I'm gonna see what we have here on the notes. The article on the left is from October 1976. It talks about the imagination and quality that was required to get the Foundry off the ground and to start the path to success. The article on the right is from March 1977, and it includes a photo of Dale Rusch, which is Randy's older brother. He's actually the oldest of the 6. Let me point to him here. That's that guy right there. Hang on, there's some big notes here. I gotta scroll down. The far right, Outlook 77 is an advertisement in the Duluth News Tribune. The bottom right photo is staff standing around the furnaces right down here that were in place when Otto took over the facility. So naturally, when you take over a business that isn't existing, you have to figure something out on trying to drum up some revenue, right? So that's where the barrel stove kit came into play. For some of you guys that have been here long enough, you're probably familiar with it. Essentially, you take a 55-gallon drum, cut some holes in it, add a bunch of castings, which I have here on this board, to turn it into a heater. And I brought this down with me because this is basically what Otto's salesman briefcase, I'll call it, was. It's very heavy. He would throw it in the back of his car, drive around, and see if he could drum up someone to bite on, selling these things retail for him. Menards, got involved with Menards. Menards was doing some of them for us. Hardware stores.
Say, Cole,
Yes.
back when we were starting up, we didn't have any business. And that's when Otto came up with the barrel stove idea. And so we had to prove our iron somehow. And that's how we basically started with that.
Yep, that's what I said. Yep. You start a business that didn't have any existing parts to run.
And customers.
Yep, you
Have
gotta start
reputation.
somewhere. And I don't know, you're in the Midwest, northern Wisconsin, people love heat. So I think it was a smart move on his part to, I always thought too, it'd be great to figure something out with mailboxes. I mean, everyone has one of those too. He also came up with a kettle warmer as well, which is on this next slide here. Here's actually the flyer for the Apostle Islands heater kit. Easy assembly, do it yourself. Basically all you needed was a barrel and the kit from Washburn Iron Works. They were sold by Menards and W.H. Hobbs. We ultimately did have to stop production of them because of UL listing purposes. And essentially the expense to get them UL listed was much higher than the revenue. So at that point, we had to go to drumming up some more work. I'm going to try and stop saying sorry guys. Right here, 1979, we added dust collection because as I'm sure you guys could imagine, we use sand molding process. It gets moved all over our facility and it can be very, very dusty. So naturally, Otto wanted to make the facility as clean and inviting as possible. So one of the big improvements he did was add dust collection. 1980 had a few milestones. Raylan Pearson, which she was supposed to be representing this. That's probably why half you guys came. Sorry, it's me now. She's Otto's youngest daughter. She joined the company and would later succeed him as president. A month later, Dave Pearson would join the company as well, which is my father. 4 of Otto's children worked at the Washburn Iron Works at some point or another. Raylyn and Rick, is Rick here? No, just Randy? Raylyn and Rick were the only ones to make it their lifelong career. Randy got involved, he did most of the trucking for the company. Dale worked for the company as well, and he branched off and started General Core. It's a kitty corner of the facility. It's directly associated with a consumable that we use in the molding process in the foundry industry. So that's right here. This little box here represents our first office remodel, which was in 1980. This was the old forestry building across the street. The top right shows the Forest Service building, and the 2 photos below it show the old office lifted. Button. So up in here. So basically, I've moved across the street. 1981 brought some big changes related to production. Capabilities for the company highlighted in the article on the left talks about those changes. Original Brown Bavaria furnace, which was the one that Otto inherited in the purchase, was being replaced with the new AJAC furnace. The new furnace would double melt capacity, allowing the foundry to melt 2,000 pounds of iron an hour compared to the 1,000 pounds that the Brown Bavaria could put out. So here's a furnace cabinet here. This is where all the electrical controls are for furnaces. We have some guys pouring some iron here. And here's the newspaper article talking about the increased capacity. So from 1976 to 81, Otto's already put a lot into the facility. Got a new office brought over, dust collection, upgraded the furnaces. 1982, brought an addition to the facility. This is the one that's going to be in green here. And you're going to see throughout the slide, we've added on, added on, added on, added on, added on. The green building shown here was erected with primary purpose of storing patterns. Patterns are the impression, are the plates that make the impression in the sand molds. With the growth of the company was experienced, additional space was required to store patterns that were being utilized to make castings. Sorry guys, he's got a lot of notes here that I have to scroll down and see them. Patterns are owned by the customer. Essentially, there's engineers that get involved. They spec out the use of the casting, and the customer owns the pattern. The reason for that is if they ever choose to do so, they can relocate patterns from facility to facility, chasing quality or price. So all of our patterns in our facility, which is about 2,700 of them, our customers do own.
Do you make the patterns?
We do some. We do make some of the patterns, but we do partner up with a lot of pattern shops because a lot of them nowadays they're on aluminum plates. They're cast. They can be cast aluminum that they machine down. They can be bronze, TCC, which is a plastic. So you need a CNC involved to do it. And we don't want to get involved in CNCing or machining because the majority of our work comes from machine shops. So they're our customer. So if we're going to be a foundry starting to get in a machine, we're almost kind of cutting off that leg. Someone else have a question?
Yeah, you said there's 2,600 patterns?
Yeah, we're at about 2,700 patterns
Okay,
in our facility.
so the people that want these, they own the patterns. Do you charge to store?
Some of them, yes. If they don't run regularly, they do have a storage fee associated to them. It's a great question because space is a premium.
Yeah, what do you mean by regularly?
If they don't run within once every 2 years. So he asked if because we have 2,700 patterns, he was wondering if we charge to store the patterns. And the answer is if they run regularly, which is an order within a 2-year period, they get their storage in our facility for free. If they don't, they're starting to get charged for us storing their pattern.
What's the biggest pattern you have? Size-wise, what?
We have different molding lines. The largest footprint of the sand mold is 30 inches by 30 inches, and then it's 16 inches on the drag and 12 inches on the coat. We will put in, on the heavy side, a casting that would weigh about 220, 240 pounds. Total pour weight would be close to 300 when you include gating and riser into that. So dimensionally, I would say, we're looking at a 26-inch diameter to be fitting in that 30-inch by 30-inch mold envelope, and up to about, total pour weight of close to 300 pounds. That's on the large side. We will make plenty of parts down into the ounces.
So what, can you give us an object so we associate the size?
Yeah, we'll make parts as big as this. A block like that. There might even be some pictures in here, hopefully, that will show you some examples of some castings. But we do go all the way down to, ounces, all the way up to 250, 300 pound castings. So 1983, another expansion. That's here in the blue. Here's an article about it. It took close coordination with Northwest Planning and Economic Development, the City of Washburn, and Washburn Iron Works for the 1983 expansion to become a reality. A grant was awarded for the project that we believe the grant was the impetus of the city revolving loan fund. And it was critical for the 50 by 60 addition. This building became the new building dock, or loading dock, and allowed for reorganizing the finishing department, including new storage racks for processing parts and waiting to be shipped. So here's some newspaper articles talking about the expansion. Here's some pictures that we were able to drum up. There's the steel shell here. Here's the new loading docks. Here's a side profile of the building. Photos of the 1983 expansion with the addition space and production capacities. Employee count brings us to 30 at this point. Here's another expansion, 1984. So some building remodeling was done. This ultimately laid the groundwork for the next expansion, which would take in 1987. In these photos, the doghouse was extended to allow the sand system to expand the Beardsley Piper automatic molding machine, making the production much more efficient. So this is the doghouse here. So we have a lot of overhead sand conveyor systems in our facility. It's how we get our sand from our 2-story, the old brownstone building. Once it's mulled up, transported out throughout our facility to the molding machines. So here's an article from July 22nd, 1986. The caption on the photo reads, "A good example of Washburn's ability to change with the times." It highlights W.H. Lemke Dry Goods, then Washburn Foundry from 1940 to 1973 under Malinowski. Transitions from ownership to a company from Medford from 1973 to 75, and then Otto purchased it from them in 1976. 1987, we have another expansion that's going to be here in the pink. That brought on plant office and future core production. The new building would be used for what we call disc molding space. The discs are used in the agricultural industry. So it's a 24-inch diameter. It's very thin and has a lot of pockets in it, and it rotates vertically. Essentially, the seeds come from out in the fields, come into like receiving facility, and they'll have different types of discs in there that separate weed seeds, corn, grass seeds. That's that disc process. Here's another additional photos of the 1987 construction. So an article from 1987 highlighted that the Foundry now had 1,300 patterns at this point. Rusch stated that the market over the last year has gotten very competitive, with customers asking for casting quotes from 3 to 4 foundries before placing work. He goes on to talk about the sand used for the mold is crucial to the success of the casting. I'm quoting him here. I think of it as a cake recipe. You need certain ingredients to produce the desired results. Every casting we make requires a variation on the same basic recipe. In this article, it also talks about replacing the AJAC furnaces. So now he's on his 3rd furnace replacement from 1976 to 1987. Replacing the AJAC furnace with a 600 kilowatt inductotherm furnace with a capacity of 3,500 pounds. 1987 also brought on another significant change, which was the addition of making ductile iron. So as I mentioned earlier in the beginning of this presentation, we make gray iron and ductile iron. Think of ductile iron as more malleable. You can stretch it a little bit, twist it a little bit before it will break. Traditional gray iron, if those skillets were out of gray iron and you drop it on a rock from this high, you would see it shatter. Ductile iron would not do that. There's pros and cons to them. Engineers will choose whether they want a gray iron or a ductile iron mix based on the casting application. Generally speaking, gray iron is really good for heat dissipation and vibration and noise. Ductile iron is more on that strength-driven application. 1988, another expansion, right here in this brown one. This is to organize the 1,300 patterns now that the facility has housed in there in the Foundry. The previous pattern storage was this green one. So you can see, as you get more patterns, you need more space. 1989, another expansion. We expanded and expanded and expanded and expanded. This is an 80 by 120 building was added, which Otto referred to as Plant 2. We also added another automatic molding line referred to as the roto match-o-matic. That roto came, I believe, out of Wapaka. He still kept close ties with Wapaka buddies that he had, which proved to be pretty crucial in the success of the Washburn Iron Works as well. The speed of the roto match-o-matic is pretty state-of-the-art for the time. You could make a mold about every 20 seconds. So it was very quick. We didn't push it that hard because the machine was kind of tearing itself apart, but it was able to pump out a lot of molds. So that allowed us to be competitive with high production run of castings. So here's a few interior. These are more recent interior photos because we didn't have any exterior of the Plant 2 from '89. Here's some molds here. You were referencing how big. This is a 30 by 30 mold. Heavier parts would run on that. This up here is the handling line where the roto match-o-matic was. That's a 1620. When I say 1620, we're talking about inches, the footprint of the sand mold. So 16 inches by 20 inches is the mold envelope there. 1991, Otto Rusch was named Small Business Person of the Year for Region 5. Then in 1992, he was named the State of Wisconsin Small Business Person of the Year. He was honored in Milwaukee at a presentation and banquet. So he was well known in the state of Wisconsin, the foundry industry, basically across the whole Midwest. As I'm sure a lot of you guys know too, that, you know, we're fortunate enough to grow up with him in the community. He was very involved, for sure. 1992, we have a small addition, a 16 by 36 building, and that's basically our sand refuse. Some of our sand, as we use it in the process, it goes through thermal shock, and we have to take some out so that we can allow for the capacity of bringing in new sand as we mold it. So that's where that sand gets housed. And then 1994, we added a 90 by 62 addition, which is this guy here. Sorry, this guy here. That's our current loading dock area here on the side of First Avenue. Basically, that was to house the finishing department, because as we were growing, we needed more and more space for doing the grinding, the finishing, the inspecting, the housing of the product, staging it up to ship out to our customers. In addition to this addition, the melt system was upgraded. So now we're on our 4th upgrade of our furnaces. We went with another industrial therm furnace. They're 3,300 pounds, but they're 1,000 kilowatts instead of the 600 kilowatts. That allowed us to basically be able to melt about 3,300 pounds an hour. Here's the inside of that building that was expanded. This is the finished department. There's a tumble blast there. And then here's the article on the mural that was done. And that was done up in 1996. And that was, the reason that was put up was to acknowledge the success of the company in the 20 years of being in business.
Are you gonna have that repainted?
It needs it. Yeah, it does. There's been talk of it, for sure, because we do get a lot of tourists and locals and stuff that come by and snap pictures of it. As I'll get into here a little bit in the future, down the line of this presentation, we've done a lot internally, spent a lot of money internally, and eventually that is going to get redone. It's just a matter of when the right time is. There we go, 1999. Okay, so 1999, another expansion. This is the royal blue one here. Additional pattern storage, and then ultimately that got converted into what it is now, which is a paint dipping operation. We had some customer demands that were requesting a red oxide, water-based, rust inhibitor paint. So we have a small dip tank in there to basically prevent some rust from happening prior to machining, and then they get their final coat. We have a select few customers that were requesting that. That's a view of the outside of that one. In 2000, we added what I call the Menards building right here. That building is basically just storing of components for maintenance or objects that don't get utilized very often but can't be subject to the elements outside. That's that one there. So, can you see? Sorry. Okay. So in 2002, that brings the era when Otto chose to retire. And Raylan became the president of the company. And I think it was kind of tough on him. I always heard the story that, you know, this is when Taylor was a senior. Nope, he would have been 20. He went into the office and asked Otto, you know, is it bittersweet that you're retiring? And Otto's remark was, no, it's just bitter. You know, that comes from a guy who, you know, his whole life was in the foundry industry. started Wapaka Foundry, what is at that time and currently still the largest foundry in the world. Came up here, started a foundry, bought one, and got it up and running. And he loved what he did. So it was kind of hard for him, but he recognized it was time to kind of pass the puck, so to speak. Go ahead, Dan.
Where were you in 2002?
2002. I was in high school. And I did work there on and off. After school, go down there, basically do the grunt work, you know. The parents utilized us, I would say, like mini slaves. The boys will do, the boys are gonna have to do it, you know. So yeah, I would come down after school, work there for 2-3 hours, doing shakeout, grinding castings, spending my time in there. Taylor did as well. All 4 of us boys spent some time in there. So 2004 brought another addition, which is the green building here. This is what we call the Hunter building. I would say this is the point of the company where things really started to pick up. It allowed us to put in an additional automatic molding machine on top of the roto-match-matic that we had. And the molding line in this one is a 20 by 24. It's kind of a sweet spot. It's very efficient for castings that weigh in the range from about 25 to about 60, 65 pounds, which is a pretty good sweet spot for the foundry industry. This is the side view of it here. And here's the handling line on that Hunter line. This is an automatic handling line. This receives the molds from the Hunter molding machine, and then we have a picture here of one of our iron pourers pouring iron into it. We can hold 110 molds on that handling line. And the castings are poured, they go through one revolution, the index into the inside of it, inside of the line right here. They go through another revolution of cooling, and then that's when they get kicked out onto the shake-up system. "2005 article highlighting making production in the Northland." You can see Raylene in the bottom right. I don't know if she's going to want you guys to see this, but there she is. There's the little Raylene. That's Dale McRae. So 2007, the grain separation disc, as I described before, made it in the Engineering Solution National Magazine. Later in 2018, we submitted that into the AFS Casting of the Year competition, and we did win Best in Class for that casting process, which is a pretty big deal in the foundry industry. That's that disc right there. We have currently, I think we have about 130 iterations of that casting. And what that is it changes the pocket size based on the use of the grain disc, whether it's weed seeds or grass or grain. 2009, we.
Sorry.
Go ahead.
Could you go back you don't have to go back on the picture, but that whole concept, somebody came to you and said, we want something that looks like this, how can you build it for us? Or the whole machine is something you guys came up with?
So it's a really good question, because this was a very labor-intensive process of making that sand disc. So that the customer owns a pattern, and the machine came with the components initially, and it's a drop-down molding system, which is very unique. Normally, to make this casting would take a very expensive core, because the pockets are angled, which in our world is called backdraft. In order to get that, you usually have to use a core. The molding machine here will separate the cope and the drag, and it will rotate and drop at the same time. So we're able to pull that that pattern without any pores. So basically we're using just our sand to make hundreds and hundreds and hundreds of pockets on either side of that casting. And in the slide ahead here, you'll see I'll talk about we did later automate that as well. To help each other grow their businesses. So this was an alliance that we formed. It was with World Class, which is a machining operation in Bayfield, Ashland Industries, and I believe Eagle Forge as well was involved in that one at the time. 2012, another expansion. This is the new office building that was put in place, and the current one that you guys see today. I think Raylan has a lot of pride on that one. She kind of designed that whole building. Go ahead.
How many employees are at the Foundry?
Currently, we are at 45 to 48 is our fluctuation. So a good amount. Prior to Northern Clearing moving into Bayfield County from Ashland County, we were the largest privately owned company as far as employee count goes in the area. And we only run one shift, too. The question was how many employees we had. Go ahead.
What's the education process to train somebody?
So the question is, what's the education process to train someone? It depends on the position we're hiring for. But generally speaking, we're in manufacturing, it's a lot of physical labor. So more or less it's orientation, and then they get paired up with the department head, and they'll do like shoulder to shoulder training for a handful of days, and then they'll kind of get released a little bit and get checked on and so on. It really varies because we have a lot of different departments in the process of making a casting, and also within those departments there's lots of individual different jobs that need to be accomplished. So it really varies. It's very it's more so like physical labor though, so it's kind of hands-on training for the most part. Go ahead.
Can you do all the jobs?
Yes, and I have. Yeah, I have. Either through. So the question was, can I do all the jobs? And I have. And from high school to coming into the company, which was 2012. I'm jumping ahead a little bit, but you'll see that. I have done every position. And I can tell you, if I can do it, most people can do it. Go ahead, Dave.
Do any of those roofs leak? Who's in charge of where the water goes?
Dick asked if any of the roofs leak and who's in charge of where the water goes. It's a great question because we have added on top of every addition possible. It was very difficult financially to just go bloop and have the space you needed. It had to happen as we financially could afford it, and the desire was there based on production. There's a few spots where the roof might leak. We did actually this past winter, as I'm sure some of you guys may have had some snow damage because we had that record snowfall, and we had some areas in here that got damaged, here and along here. We recently had that just a few months ago fully stripped off and replaced while we still were in production. We partnered up with a company called Northwest Builders, which you know, Daryl's in that company, Mr. Daryl Olson. They came up and were able to, during the day, strip some sections off while we were producing, and then at night they would close it up. And water runs downhill. So here's the office here, the front office that you guys are mostly familiar with driving by. Here's 2016, brought her 40 years. And 1 year after that, 2017, is when Otto passed away. So here's a newspaper article talking about the 40th anniversary my dad, Dave, Raylan, Darlene Anderson, which is back there. She's a long-time employee. How many years, Dar?
36.
She worked for us for 36 years. Wow. Yeah, great. She still stops by. Yeah, give her a round of applause. I believe I still see her 2 to 3 times a week, just coming down and checking things out. Just making sure the younger generation's doing a good job. Yeah. And then there's a picture of Taylor and me. And there's Rick. So he was still in it at that point. Later on, Rick decided to retire, I believe in 2019. So this is kind of mine and Taylor's era. I know a little bit more about that period of time in the history of Washburn Iron Works than the previous, and I'm sure you guys are probably more interested in the older stuff. But essentially, 2012 is when Taylor and I came onto the scene, and I think at the time, our parents were somewhat relieved because they didn't really know what the future of the company was, where it was going to go. There was no real good succession plan. In 2012 is when we did that office building, and that is basically was Taylor's first little project. He was the project manager of that whole project. I came in 2 months after him and was thrown into the plant to learn the ins and outs of the process while the new office building was being built. So within that process, in 2013, I saw a need to start automating. Back to some of the previous questions, what kind of training is involved, needed in our facility. I mentioned it's very labor intensive. We had to get with the times and kind of make the job physically easier. So in 2013, I started doing research on robotics. I found robots that I like. This one's an ABB, Foundry grade. These are big. I mean, that robot's probably this tall. It can pick up, that one can pick up 220 pounds on the end of it, and we are utilizing that for our finishing. The finishing is probably the least glamorous position we have in our facility, and that's where we're taking the castings, grinding them up, getting them ready to ship out to our customers. So this robot was implemented to take some of that finishing load off. Here's the other robot here. That one was implemented in 2015 after showing and proving the success of the 2013 robot. All this stuff we did in-house. We didn't bring in anyone in. As you guys are familiar, we're in a small community way north in Wisconsin. The resources are very limited up here. To bring in engineers and stuff, it just costs too much money to come up from the cities. This robot here was implemented to mold those discs, those grain separating discs. That was by far our hardest position at the time in 2015, and we were having routine back strains. So naturally we took the success of the robot and the grinding and we implemented it into the molding system. And today, as far as we know, we are the only foundry in the world that actually utilizes robotic molding for their molding machine. Most of the time robotics are used, it's more of a handling process. Go ahead, Randy.
Cool. When you put the robots in for the robot for Carter Day molding, what was your scrap before you put the robots in, and what did your scrap go down to after you put the robot in?
It's a great question. So he's asking about scrap. Let me touch base on that a little bit. So in the foundry industry, there is scrap in the process. It's whether it can be sand related, it can be temperature related, it can be an iron pour not pouring effectively, it can be slag that gets into it, it can be warp, which that warp refers to the molding of the discs because that's a very thin, large diameter disc. Prior to the robotic molding, the disc scrap was about 12 to 16%. So what that means is we were losing 12 to 16% of the castings we were making. It was very high scrap. When we implemented the automatic or robotic molding, we dropped down to 4 to 5%. So it was a pretty drastic improvement. We had a very consistent molding hardness throughout the process. The robots never call in. They're very reliable. With that being said, all of our robotics and automation in our facility did not replace any person. It actually created more jobs, I would say. We just basically took difficult ones and made them much easier. Currently, plant-wide, we run about 4 to 5% scrap plant-wide throughout all of our processes. So back in 2019, we added a new shakeout system here. As you can see, we moved internal. At this point, we were kind of done expanding, at least we thought, anyways. And we focused our effort on basically improving process, efficiency, quality, efforts to make the job easier. All of that was implemented. So this was 2019, new shakeout system, larger shakeout system. We used to chop saw all of our gating off of our castings, and we went to what's called a hydro wedge. So we use a hydraulic bill that snaps it off, so it's much safer for the employees and way easier. Here's a BMP upgrade. So this replaced the Roto Matchable-Matic. This was in 2019. It's also 1620. And then here is the Otto-matic. We had to. This machine was brought in 2016. I know it bumps around from that BP to this one. This is the latest, greatest Hunter molding line. It's got the latest technology. It's a 2024. It's heavily automated, has tons of sensors, tons of adjustability to it, and it will pump out still about a mold every 20 seconds if we really want to push it hard. Here's the best in class article back in 2018. Washburn Iron Works. So with all the work that we put inside, so that was basically tailored in my era, 2012 to 2022. We basically were able to increase production over that period of time by 60% with the existing equipment and doing some automation. And that's huge in the foundry world. Compared to 1992 to 2017, 2018 numbers, it was 100% increase in production. And there was an article written up here about the improvements. Here's another edition. Yeah. This one is the latest one. In 2022, we added that really pretty nice new building in the back of our facility. It's 13,000 square foot. It basically is the stepping stone of where we're taking this company in the future here. We're gonna upgrade our furnaces, which I believe that would be the 5th time now. Currently we run 3,300 pound furnaces. We're gonna upgrade our furnaces this year. We have new ones coming in. Those are gonna pump out 6,600 pounds of iron. Much faster too. We can do the 3,300 pounds in about 45, 48 minutes on average. And for context, any given day in our facility, one shift will pour between 36 and 39,000 pounds in a day with one shift. Our yield is about 68%, which is very high for the foundry industry. Job shop or medium-sized foundries like us run in the 50 to 54%. We focus on increasing our yield essentially for every pound of iron that we pour, we're yielding 68% of that is going to be a casting, because you have the gating system, you have your scrap and all that. Go ahead.
Do you have any difficulty getting the extra power you need for these bigger furnaces?
So the question is, do we have any difficulty getting extra power for these bigger furnaces? There's a large upgrade that needs to happen on the power side for our facility. Because we run 1,250 kilowatt furnaces right now. And for context, we use more energy per month than the whole city of Bayfield. For context, we use a lot of power, and that's part of the driver of innovation and efficiencies and whatnot. Is to the whole foundry industry is very energy heavy, the demand. So yes, we have to bring in new power supply, a whole new transformer, whole new line system coming in feeding the furnaces, which are going to be placed in the middle of this facility here.
But
And then
Excel can provide you the power.
they can provide the power, yes. Excel Energy can provide the power, yes. Yep. They have enough. They have their substation down by us that can handle the capacity. Yep. But currently we do use more than Bayfield. Essentially, we're going to be not quite doubling our power consumption because there's a lot of innovation that we're doing.
But you pay a lot less per kilowatt hour.
Yeah, yeah. I don't. You don't want to see our Excel. It's very large. Go ahead.
Yes, on the topic of future expansions and ideas and things, do you ever consider any other metals other than iron, like say maybe bronze? It seems as though there might be a market developing for bronzes within the area with a developing and expanding art community.
Yeah, so the question is, with the expansion, have we considered dabbling in different types of metal, like bronze or whatnot? I won't say no, but because I don't want to be so close-minded where we might not potentially dabble in that. There's not a ton of foundries in the iron world that will commingle because of the process that is in the foundry and the potential for contamination or mixtures, and space to have different scrap allocated for that type of material. And usually those foundries also have designated furnaces for that type of material. Most of those metals like bronze and brass and all that, they're smaller core, smaller furnaces, take up more footprint. But it's anything's on the table at this point, I would say. So here's the new building here. Part of optimizing is these are 3 scrap receiving doors. So we bring in 3 different types of scrap material. It's a scrap steel, and then a lot of that's come from Kurt Manufacturing, so all the hitches, so all their waste and drop material we use, and we'll melt it down and turn it into a usable part. We also use bundles, which is a lot of the material from like the punching industry, like the old school cans and the punching industry, where they take a lot of thin sheets and they're punching out shapes, and we're using their waste in our recipe to make a cast iron.
Generally stuff, the scrap is generally stuff you understand the composition of the various things, so you can keep your quality control up.
Yep. The comment was, do we generally have an understanding of the chemistry or the composition of the scrap coming in? And the answer is yes. We have to, otherwise we don't know what we're making in our facility. We have standards for our suppliers to make sure they provide us material that meets our specification. And the other door here is pig iron. So pig iron is basically like the most benign, rare, like softest iron in the rawest form from the earth. Ours comes from Africa. Yeah. Comes from there, comes all the way up to Mississippi, gets into the metro area on a big barge, and then it ultimately gets trucked to our facility. So yeah, we use a lot of rare earths and silicon, carbon, globally. A lot of our stuff comes from India, China, Africa, all over the place. That's why you see a lot of trucks going by and making deliveries. Part of the new building addition, recapture the waste heat off of our future furnaces. So our induction furnaces have to be cooled continuously as they're being used. Even as they're shut down, they have to be cooled for about 8 to 12 hours before, otherwise the copper coil will melt down. So there's a lot of waste heat involved. So we had desire to capture that. As far as we know, we're the only foundry in the Midwest that's recapturing the waste heat from the furnace cooling and putting it into in-floor heat. There's another picture on the side there. So then this brings us to this big guy here. We worked very hard the past year to get a grant, and it's called an EIGP. So it's an Energy Innovation Grant Program. And that's why we put that building in place, so that we can utilize the energy innovation that we are putting together here basically this year. We received a $1 million grant for our process that we're implementing, and that's the automation of the scrap receiving. So you saw those 3 doors that came in, we bring in 3 different scrap materials. We're designing and developing our very own fully automated magnetic crane. No other foundry that we know of has it fully automated at the extent that we're going to do it. That's where our energy innovation and efficiencies come from. Essentially, the furnace operator will be able to go to a screen and it'll say, I want a charge of X material. The crane will go pick up different ratios and recipes of the different material that we have in our facility. It will pick it up, it will tear it, it will figure it out, it will trickle some down, and it will weigh up that charge for the furnace operator. Currently we have a guy that's doing it. This would improve the process flow, improve the energy consumption, and improve our quality. On top of that, we're doing the new furnaces, which is basically going to double our melt capacity. So we'll be able to do 6,600 pounds in 36 minutes. It's a lot of power going through those guys, compared to the 3,300 pounds in 45 to 48 minutes. So that means that our plant doesn't have to stay running as long, our motors aren't running as long, we're using the latest, greatest induction heating. They're the most efficient furnaces you can get to date. There's a lot of controls involved, and we're doing heat reclamation on the floor, and then with the magnetic crane. So that building was kind of the stepping stone, and now we're in the phase where all this is actually coming together, starting about June of this year. Go ahead.
I'm somewhat interested in your background and training. Metallurgy is a pretty specialized field. You talk about chemistry. Innovation is something that is cutting edge. You obviously either picked it up on the job, or you have a rather incredible background that we don't know about yet.
I wouldn't say incredible. So the question is he's intrigued on the background of my knowledge and experience, and I think, more broadly, probably my mom, Raylyn, and my brother, Taylor, and everyone kind of associated with spearheading this company. I think a lot of it we got from our parents, who ultimately got it from Otto. He was a very hardworking man, and he believed in, you work for what you have. And that trickled down as far as the work ethic goes to my mother and my dad, and it trickled down to us. So I would say work ethic is the large base to that. And then also having exposure to this type of company at a young age. it's very mechanical. There's a lot of moving parts to it. And then also being isolated up here in northern Wisconsin where you don't have a lot of resources. So I did not go to school for metallurgy. I know a little bit about it, but Taylor's the metallurgist in the company. He did not go to school for metallurgy, but he dove in and got the knowledge required. We do have a spectrometer in-house which checks all the chemistry and the metallurgy of our base iron. It's a lot of just exposure and drive to figure things out as you need to, and being self-sufficient, which you pretty much have to be up here in northern Wisconsin. I taught myself how to do robotics programming just by spending 4 to 6 months research. Then when it came on site, just, I want to say, just playing with it, you know, and then trying to understand its code and be able to analyze its future applications. And it's kind of gone on from that. I think it's a lot of a family affair and work ethic, and then just exposure and drive to get where we're at today.
It seems that, you know, you're putting a lot into enhancements, machinery and expansion, which suggests there's really plenty of demand.
Mm-hmm.
And, you know, I don't know the industry, but I contrast that to all the castings that are done on the cheap in India and China and
Yep.
parts of the world. It's actually very impressive that you're expanding against that backdrop where there's probably very competitive prices.
Yes. This gentleman brings up a good point. He's impressed at how much we are expanding in our facility, which suggests that there's demand, and there is demand. And to his point, we are competing globally. We do compete with India. We do compete with China. We do compete with Mexico. I mentioned we work with Caterpillar, John Deere. Those companies actually have their own foundries, right? They'll have their own custom-made foundries for specific product lines for their own products they're producing. But they're not foundry men per se. They know that there is demand or a need for a lot of individual foundries in the country and in the world that would be better at certain product lines than they would be. And there is some reshoring happening. A lot of the casting world shipped out to China many years ago. China with their, you know, trying to implement better regulations over there, which, you know, is debatable. And their desire of a better standard of living is increasing, and they're starting to be a little bit more expensive. Which brings us to India. So it's looking like the new shift is going to be towards India. And those castings are cheap, but they also have their own issues with customs, shipping, coming overseas. Prior to COVID, to get a shipping container on one of those big ships coming over was $2,500. At the peak of COVID, it was $30,000 for one container. So all those expenses start to eat up your margins that you're getting. And to be frank, the quality of the castings made in the United States, more specifically in the Midwest, is second to none. You can kind of go through facilities, and we have, where you can tell if a customer has a stack of castings lined up, like, those are from the United States, that's definitely from China, that's possibly China or India. And there is some reshoring coming back from that. So demand is there, but part of us being able to compete globally is a lot of these projects that we've been implementing over the last 15, 20 years. Automation, improving of the process, doing things more efficiently, more sustainably. Our ultimate goal is to go to 4-day work weeks and also be able to double our existing production.
That's my goal too, by the way.
Yeah. Everyone wants to work less, but get paid the same, right? That's the trend, and we see it. We're not going to fight it. We're going to try and position ourselves to embrace it as best we can. Go ahead.
You said earlier you have two robotics and none of them replace any men. How many robotics do you have now?
Yeah, so he mentioned earlier we have some robotics in the house, which we do, and that none of them replace any men, and how many do we currently have? 2013 we put in the grinding one. Still takes a person to feed it, to inspect and hand it parts, and it grabs it, grinds it, and it boxes it up. So that's one. 2015 we did the molding one. We still have the same two guys, not necessarily the same people, but the two positions that are still involved in molding on that robotic molding line. And then we're currently, to help with improvement of our production, or increase of our production, we have 2 more robotic grinding cells that are probably due to be finished in a month or so.
So you have 6 total?
4 robotic arms, manipulators I'll call them, and then we also do have 2 grinding cells that are called Behringers. They're an automated thing, but they're not like a robotic manipulator that you saw in the pictures before.
Okay, my second question, how much of your product is international and how much is, say, local or within the continental United States?
So the question is how much of the product line that we make international versus more regional or in the United States. Some of our parts do go overseas. It's very small. I would say it is probably in the 0.5% mark. It could be a little bit more if you want to, if you want to include Mexico. We don't always know where our parts end up. We get an engineered print. We'll have an idea of what it is, but sometimes we don't know what it goes into. Like, we had a conference call with Kat, and we've had this part for years now, and just this week I found out it goes in their D6 dozer, their medium-sized dozer. Regionally, I would say we're probably in the 70%, which, the Midwest area, but we do go all the way over to California, Texas, New York, some stuff in Florida too. We make some fire truck components that find their way in Florida. But most of it's agricultural stuff, and it stays within the Midwest area.
Have you got any government contracts?
Yes, we do. So the question was, do we have any government contracts? We do have government contracts. That's more of a recent thing for us. I would say in the past 4 or 5 years. We have some government contracts. Some are defense for our military. Just kind of varies. A decent amount. That is increasing for us. There's a ton of paperwork involved to want to make parts for the government.
You mean you're not making a $50 hammer?
It's probably a $150 hammer. Joe.
Cole, you're doing a good job.
Thank you.
Shop teachers giving you
Yeah.
thumbs up.
Thanks.
I just want to bring something forward. I came here in 1976 to be the high school tech ed teacher, the shop teacher. And I took a walk down Main Street when I got here, and I was just cruising out, checking places, checking businesses in town. Olson Building, Hugo Ungrown over at the hardware store. Pershing Kirshner was over, at the drugstore. And the Andersons, of course, were there. And so I kept walking down the street, and I saw this old building. And the brownstone, I thought, man, that's kind of a cool building. And I walked up, and there was a door open. And it was dark inside there.
Yeah.
And I walked in, and like you said, there's this one light bulb just kind of
Just
glowing
one,
in the dark.
hanging in the middle.
And I thought, man,
And you couldn't see much around it.
Dracula's in here or something. And so when I was looking around, all of a sudden somebody jumped out at me, and it was your grandfather. And he was like covered, he was
He's
like
getting it all, trying to get the place up and running.
Yeah. And all I could see was his eyeballs, because all the rest of him was black from Foundry sand.
Yeah.
And he just said, "Can I help you?" Because I'll tell you, he was a formidable guy. He wasn't much taller than me, but he had shoulders about this big.
Yeah. Yeah, he was an athlete.
Well, I'm a new teacher here in town, and I said, this is a foundry, isn't it? And he said, you're darn right it is, and I'm gonna have this foundry up and running in a short order, you know? And he said, I'm gonna get this going. And I told him about what my responsibility was at school, and I just mentioned, I said, you know, in my high school in Chicago, I had a foundry. I had a foundry at Milwaukee Technical College. I had a foundry in Manitowoc, Wisconsin, the first 2 years that I taught. And I had a foundry also at UW Stout. And I said, I'd really love to have a foundry at Washburn High School. And he said, you know, Joe, you just get to work over there on setting up. Get set up over there. I'm going to work on my foundry, and we'll work together, and we'll have a foundry set up at Washburn. And within, Otto got the foundry going down here, and I worked with kids, and we set up our own ramming benches and built all those things that we needed. And the first day that we poured metal, and we could only pour aluminum, I couldn't pour iron, I couldn't get that much heat over at school to pour iron. And I invited Otto Rusch to come to our first pour. And man, let me tell you, I was praying because I didn't want to have a cold shut on this thing or something and be pulling this casting out for it not to work. Well, we poured the casting and we shook it out, and here's that casting.
Wow. Yeah, look at that.
And we gave this
Aluminum foundry man.
Otto Rusch, and it hung behind his desk for at least 30 some years.
Wow.
And a few weeks ago, I saw this hanging on Randy's mailbox. I said, I've got to bring this. I've got to bring this over to tonight's meeting.
Yeah.
But I just want to say that anytime I ask for any assistance related to the foundry at school or anything in the tech ed department at school, Washburn Iron Works was there. Your grandpa, your mom and dad, and you guys.
Yeah,
and
appreciate it. Thanks. I remember the foundry class you had. I was one of your students. I still have my aluminum Roadrunner from your class.
Yeah, they're all over the place.
Yeah. It's in the garage next to my workout machine. I literally see it 4 times a day or 4 times a week. It was from your class. I couldn't just get rid of it. It's memories, Joe.
Cole, this woman has had her hand up for a while.
Sorry.
And I'm going to let her ask a question, but I'm so appreciative of the audience tonight. You know, this is a little bit longer program than we usually have.
I was hoping, yeah.
And I'm watching
Sorry,
the
guys.
audience and I'm waiting for the wiggles and the, you know, and
wanting
that
to
hasn't
go to the
been happening.
bathroom.
You know, you're telling a great story, and thank you for your very, very wonderful questions, but we'll just have one more tonight.
Yep.
I was just wondering, since you've done some of these, you've created some of this robotic machinery and you're thinking other foundries might not have it, at least as far as you know, have you considered licensing the work that you have done to some other foundries to be able to recoup some money that way?
Yes, so some of the stuff, we've looked into it, and currently there's a potential that we might license a certain aspect of our implementation of our equipment happening this year for future use in the foundry industry. I won't get into too much detail on it, but yes, we have considered that. And I actually have had like a foundry inspector for John Deere who's been in hundreds of foundries globally. Come in and see our robotic molding line and say specifically that he's never seen that in a foundry before and that we should consider patenting that process. So that was kind of like a pat on the back there, and we are currently working on another process that has some pretty good potential that we may investigate patenting it and then providing it to the foundry industry to implement it. So yeah, it's a good question. It's kind of interesting. A lot of it's coming from us up here, you know, little small town, Washburn, small foundry, but I guess when you're involved and you have a desire to make improvements, that's where you end up. So.
Thank you very much.
Yeah,
and
thanks everyone.
I have to say, this is a pretty talented guy, right? And you really did a great job of filling
Being
in.
thrown into it.
The other thing I want to let you know is he must be an amazing father, because his 3 children have been sitting in the front row all evening, and you didn't know they were here, right? They've been really, really attentive
Thanks,
and well
kiddos.
behaved, so yay. So thank you very much.
Thanks, everyone.